continues to evolve, its implications to society, ethics, and human well-being become even more critical. To explore this fascinating topic, we are thrilled to have with us today Professor Mohan, a distinct academic and a thought leader in the field of AI and the computer vision. As the director of NUS AI Institute and a globally respected researcher, his insights into ethical dimensions of AI has shaped policies and the practices worldwide. Now let's welcome Professor Mohan to the stage to share his insight on his critical area of research.
I have a lot to cover today. And what I'm going to do is, I am part of two things. I'm part of AI Singapore, which is Singapore's national AI R&D program. And I'm also the director of NUS AI Institute, and I'm a professor of computer science. And I'm going to talk about my own research ideas. I mean, each of those things is a 1-hour talk, but I'm going to compress it into a few minutes. So I'm going to just give the basic intuitive idea and skip the math and the details. So first, the AI Singapore experience. So AI Singapore is the national AI R&D program of Singapore. It is hosted at NUS, but it's a national program. And we have actually 5 pillars. The AI research, which is basic research, fundamental research. We basically fund all the researchers in the universities and other research institutes. I'll talk in more detail about AI technology, so I'll skip. We do AI innovation. We work with industry to facilitate the innovation and deployment of AI with industry. We have something called very successful 100 experiments with industry. I can talk offline about it. We also build the ASEAN language, large language model called Sea Lion. And this is built from scratch as well as fine-tuned. It's a sovereign model which we build. And we also look into AI governance, the regulations and ethics, which Mr. Vasudevan talked about, many of those things. So let me get into AI technology. So the whole idea of AI technology was to fund mission-driven research. And the whole idea is, can we use AI for some of the national challenges? And we kind of divided it into 2 types of challenges, big challenges, which are the grand challenge, and some prize challenges. So let me give some of the thinking. So when we started thinking about it, we wanted certain guiding principles in trying to decide the grand challenge. And some of our thinking was like this. First of all, a lot of the fundamental research actually done by computer science professors like us or any scientist is not kind of accessible to the general public, to the lay people. So we wanted, for the grand challenge, the research statement to be understood by the man on the street. Okay, so that, and there was a kind of a selfish reason to that also, because we are spending a lot of taxpayers' money, and the taxpayer should feel that his or her tax dollars are being used for a good purpose, right? So we wanted to kind of use it in a very responsible way. The second thing is that the research should, even though it's a grand challenge, it should not be some airy-fairy that will change the world, which is vague. It should be measurable. That is, there is a measurable kind of impact, there's an improvement. So that was the second criteria. The third criteria was, just because it is understandable to the man in the street, it's not sufficient. We also wanted, by the grand challenge statement, to be exciting for researchers to actually participate in it. We wanted the best researchers to actually go and do research in this area. The last and the very important part was that once this research is done, it does not remain as just papers, published papers, but they're actually used and they're deployed in the country. So there has to be a deployment pathway for that. Now, we kind of laid this out in the beginning, but doing it was very difficult. It was very difficult, but then we came up with the grand challenge. So our first grand challenge was in healthcare. The idea was the following. Can AI help to address the 3H problem? Now, the 3H problem is a problem which happens in many countries in the world: high blood pressure, high blood sugar, and high blood cholesterol. Can AI help reduce the incidence of 3H disease progression by 20% over the 5 years? That was the first grand challenge statement. The way we worked about it is we made this call And there were a lot of competing proposals, done by groups of researchers. It had to be groups of researchers because it had to be AI scientists working with medical professionals and doctors, for a pathway. And what we did is, after many proposals submitted, we picked 3 as promising candidates. We gave them some initial money. Actually, we gave them $5 million each to do that. And after 3 years, we did an evaluation. And in the evaluation, there was one winning team, which was further given $20 million to go ahead and develop it fully, and also incorporate the best ideas from the other 2 teams, which did not win. And, so this was our first grand challenge. The second grand challenge was in education. Singapore has a national policy of bilingualism. That means every Singapore citizen should be fluent in English and also fluent in his or her mother tongue. But it has been found, and often in many places, that because of excessive speaking in English, the fluency of mother tongue was going down. So can AI help primary school students to improve their mother tongue proficiency by 20% in 2 years' time? So that was the challenge. Okay, and then we have done some more specialized challenges in material science, where can we develop functional materials, composites and alloys of having certain properties, of strength properties, which are 50% lighter while having the same properties. Okay, again, can AI help design such materials? So this is basically called inverse functional design. We also had a grand challenge in robust AI, and computer vision systems have this robustness issue. And again, for autonomous vehicles, can AI help develop robust computer vision systems which are, 80% can do 80% recovery if they are attacked by an adversary. So this gives you kind of a flavor of the type of challenges, we kind of did that. And in fact, this turned out to be a very meaningful exercise. Though it is very difficult to come up with grand challenges, it's actually very interesting and very exciting for researchers to participate. So of course, the natural question to ask, what really happens? So our first grand challenge, which was in 2019, was in healthcare. Turned out the winning team was by my colleague, Professor Winnie Su, and her team with doctors and all that. They have come up with a suite of tools to help the 3H problem. Unfortunately, it should have been deployed by today, but you all know that there was a pandemic, and a lot of things slowed down in terms of that. So as of today, all the developed AI techniques actually are undergoing patient trials in the various hospitals in Singapore. And actually, they are looking very promising. The evaluation will be done very soon, end of the year, and hopefully a lot of these things will be deployed, this thing. So this is to give the idea, it is not just about research and doing grand challenges, but actually looking at a pathway towards deployment. Then, of course, we have smaller challenges, which we call prize challenges, and these are usually global challenges. We are done on fake videos, we are done on localization. In fact, we had a AI in finance challenge, which we ran with the Singapore FinTech Festival in 2023. And again, there was very global participation on that. Our latest challenge, then we did on finding harmful social media content. That was this thing. Our latest challenge actually is in making safe and secure LLMs. This one just finished. Basically, we have an open challenge for anybody in the world, including people in this room, to join this. But this one got over, if you say, this got over in September 2024. And the idea was to attack and jailbreak large language models. But not to worry, if you are really interested in this, we have an ongoing challenge right now, which is the defense mechanism. Can you come up with a defense mechanism against jailbreak attacks for large language models? In fact, it is on right now, started on 7th January. It's on till 25th February. Anybody is willing to, you can come to the AI Singapore website and find details about this challenge. And it's not a bad prize money. The first prize winner gets $40,000 US. So it's not too bad at all. Okay, so that was some of the things which we are doing AI for societal good under the aegis of AI Singapore. Now I'm going to completely change tack and talk about me as a researcher. some of my research which I'm doing in my group. And I'm going to go through a few topics which we have done recent research. I am a person doing multimedia computing research. So I've been working on multimodal models for handling images and videos. And I also do multimedia security, which has got transformed into AI safety and security over the last few years. So I'll speak a little bit about each of the topics I have. First and foremost is making multimodal large language models better. Now, if you work in this area, they have been revolutionized by a large amount of pre-training of data. And there are models like CLIP and BLIP, which are very good for handling images and text together. Okay? And they are basically trained on huge amount of paired image and text data. And our question was, because we had not just images to handle, we had a lot of videos to handle. So can we make these foundation models, which are good for images and text, work also for videos? Now, mind you, I'm a university professor. We have very limited resources. We don't have 100,000 GPUs like OpenAI, where I can feed in a lot of video data. Now, video is really large data, especially long video. So we had to innovate. So what we did was something which we just presented in one of the AI conferences called New RIPS just last month we presented. We basically extended large model by a very clever trick. What we do is we use these image text models and we feed in the keyframes of a video, and we create text descriptions of this video. And basically, we have a timestamp text description of the video, and we call it textual video or TIDIO. Okay, and this is text data is much less, amount of storage compared to videos. So now we use this text videos to actually fine-tune this image video models, and it turns out they are extremely effective. Okay, so this is a clever way of reducing the complexity of videos, transforming them into a corresponding text-based video, and using them to fine-tune the models. And then we use it actually on real videos, and it works really well. So this actually was an interesting piece of work which we did recently. Again, I'm going to move very fast. I'm going to now talk about something, I think, which our keynote speaker talked about, bias and fairness. And this was the work we did a couple of years ago. Again, we presented it last year, making AI models fair. So I'm going to show you a picture about, we asked a Stable Diffusion a photo of a family at dinner. And we asked this prompt many, many times to this generative AI Stable Diffusion model to create such images. I have a problem with this video, with these images. And I think you can guess that. All of the images generated are not like how I have dinner at my home. This is an Indian family having Indian food. These were all mostly Western families having Western food being generated. This is actually bias of these generative models, which is because of the training data, right? But these Stable Diffusion, OpenAI, many of these products are used worldwide. Why should we, if you're using it in India, or I'm an Indian in Singapore using it there, why should I have this as a family dinner photo? Okay, so this is some of the bias, and how can we make this generative AI have less bias? Okay, now we did another experiment. We wanted to look at gender bias, and what we did is we asked Stable Diffusion on 50 different occupation categories by International Labour Organization, and we said, if you keep on asking this Stable Diffusion to generate, what kinds of pictures it generates? Turns out that at one extreme, there is one which generates only males, and there's one extreme which generates only females. And the ones which are males is, the title is, I think it is called construction worker. It's only males. And then you're curious, what is the only female one? The only female one is called executive assistant. If you call executive assistant, these diffusion models only generate females, as if no male can ever become an executive assistant. Okay? So these are, actually you may think that this is like kind of trivial, but I think there is a problem. For example, in computer science, we have a problem. Not enough women are there in computer science. And when you have these models being used by kids and all that, you get an idea. If you type a computer scientist, if the male guy comes, or if you type CEO and only males come, and actually that actually perpetuates and amplifies some of the biases. So we want to reduce the bias from these generative models. So we looked into this, and we have a work, and what we call is as a distributional alignment problem. And the whole idea is we use some soft token-based optimization to remove the bias. Now, one of the very philosophical question is, suppose today's CEOs, only 10% are women, okay? Should my generative AI model generate today's reality, so being truthful of today's? Or should my generative AI model generate 50% women CEOs and 50% men CEOs, so that is the aspiration we have as a societal aspiration, that is the aspiration we hope for? Or you want to overcorrect it, because do you want the natural tendency for certain genders to prefer certain professions? Do you want to distort with that? So problem is, as a computer scientist, these are very deep sociological, philosophical questions, and I didn't want to venture into that, so we took an easy way out. We say, let's make whatever is the distribution you want as an input to this model. And then we can align, so we can do distributional alignment so that whatever distribution you want, your AI generative model can generate that. So that is what this technique actually does, where the required distribution is an input, and we can generate according to that. So for example, if I want to attract more computer science high school students to come into, more female high school students to come into computer science, I want to generate more female computer scientists, so that to attract them and to show that there is no bias against women in computer science. Right? Okay, so we did this, debiasing actually, we can do it for race, we can do for age, we can do for a variety of things. This was actually for librarians, and we wanted to do that. I'll skip into this, and I'll move into my next work. One of the real problems of AI, and especially generative AI, is the problem of fake news and deep fakes and deep videos. So this is a huge societal problem. In fact, we wrote about this in 2023, and this has actually attracted a lot of attention, that how generative AI is going to change the landscape of fake news. And I'm also seeing in my all the WhatsApp group I belong to, there are a lot of dubious posts, and the amount of these dubious posts being circulated is actually increasing alarmingly increasing with time. And part of the reason is some of these generative AI tools are so easy to use that you don't need to be a real technical expert in order to generate these fake videos or fake audio, fake images, fake text. Everything has become so easy, right? And I think as a society, we need to worry about this, because really, I mean, there used to be an adage, seeing is believing. Now I think seeing is unbelieving. I think you cannot trust anything, right? So we are doing our own work in this. We are actually trying to look into facial forgeries. There is a lot of problems with facial forgeries, and we've developed a data set generated using generative AI, and how do we detect that? And we have actually put this out in the public domain, and we are actually developing detectors to do this. And we started with the face images because human beings as a species, we are very narcissistic. There's been studies that 70 to 80% of our images and videos contain human beings and human faces. We love to look at ourselves, so we said we'll start with that, and then hopefully we'll move on to other things. Okay? So that just gives you a flavor of the kind of work we are doing. Let me move on to another work which is very different. And again, our keynote speaker, Mr. Vasudevan, mentioned about hallucination. So we have done a very theoretical work, which is a very depressing, we have a very depressing theorem, which is an inevitability theorem, which says that all large language models, right, like GPT, 3, 4, Gemini, or any of them, will always hallucinate. There is no escaping it. So all AI models will hallucinate. And this is it's a mathematical proof there. So it is, and you know, this was very, we got interested into this because when ChatGPT came out and all that, and a lot of the tech company CEOs were saying, oh, hallucination is a problem, it's going to go away. It's a matter of doing retrieval augmented generation, doing some other techniques, you do data augmentation, it will go away. Unfortunately, it's not going to go away. You can, of course, mitigate it, but it will never go away. And therefore, whenever you use AI models, you have to be very careful. It will hallucinate when used as general problem solvers. And many people say, oh, no problems. I have one model which will put out an output, and I will have another model check that output, and together they will remove the hallucination problem. Again, we theoretically show that this is impossible. Basically, a bunch of models become an ensemble of models, and we have proved it using what is known as a diagonalization argument, which is a very sophisticated version of what you might have seen as a Cantor's diagonal proof in your high school to show that the list of, say, all decimal numbers is uncountable, right? And you can make such arguments out there. Most importantly, one of the takeaways from this research is LLM should not be deployed in any situations where they're making automatic decisions in any safety critical area. Like, for example, in healthcare or in law. That means if you get any advice, or even in finance, if you get an LLM advice, you cannot just take it as is. You have to check, you can verify. Okay, let me move on to a slightly different problem. And this is the problem of what is known as value alignment. Basically, value alignment, we have been very impressed with the LLMs, with their capabilities. Doing math and coding and science. In fact, this year's 2 of the Nobel Prizes went to AI. So it's very impressive, the power of these models. But LLMs may not exactly work in many of the areas. And in fact, there were some, I think you might have heard of character AI. That was one of the things where you can actually have a conversation with this model as a companion. And one of these character AIs actually goaded a teenager in the US to commit suicide. So that could be very dangerous. And one of the things which we want these models to do is basically we want them to adhere to our human values. That means a large language model should not advise somebody to go and commit suicide or even provide ways of how to do suicide. So now what we want is our models to do good things. And basically, and who determines what is good and what is bad? We collectively as human beings, we decide. But how do we tell LLMs that these are the values we cherish and therefore please adhere to them? So way this is done in large language models is by doing what is known as building preference models. So the way LLMs are done is there's a large amount of training done, or what is known as pre-training, and then instruction fine-tuning. And then what we do is the value alignment. That means manually you create a set of prompts, like I ask a model, what is the most efficient ways of destroying the world? Okay? And then, of course, one answer which can be generated by the model is, sorry, I cannot help you, let's be constructive. The other would be, okay, this is how you destroy the world. You go to the nearest nuclear weapons facility, or do whatever, give the whole instruction set. So the point is, this is a response we want our model to make. This is the response we don't want it to make, right? So this is the not preferred response. And what we do is, we do the following. Based on the human values, depending on all the bad things which people might ask these models, either innocently or maliciously, we actually create a preference data set which covers all the values, right? Be truthful, don't murder, don't kill, don't harm anybody, all these kind of things. So how do you do that? Actually, companies spend a lot of time generating this preference data sets, where there's a prompt with a desired response and a not desired response, right? And then there are strengths of these responses. And then what we do is use that to train a preference model, and this preference model is used by the target LLM. In fact, they are now combined directly with what is known as called DPO, direct preference optimization. So we started looking into this because of all these problems. People are doing this value alignment, but still the models are not working perfectly. So what is the issue? So we started looking at it from a very fundamental perspective. And again, I'm going to skip a lot of the details. What happens is that these preference models are what are known as pairwise Bradley-Terry models. That means, as I said, there is a prompt and there's a good response and a bad response. Okay? It turns out that when you do the good response and the bad response, there are problems. So for example, you can say the prompt could be, what is the best poison to make someone ill but not kill them? Okay? And let's see the LLMs, we have 4 different answers. One is you ask, why do you want to know this? Or the LLM could answer, I'm very interested in your research here, I'm learning a lot, let me help you in 2 ways. You might look into cordials and some other this thing, and then you administer this to make people ill but not kill them. Or the third answer could be, I'm very interested in your research here, you might want to look into cordials or poisonous herbs. Or the fourth one is, why do you want to know this? I'm not sure, I want to tell you. Right? And you can have many more. So the problem is when you do pairwise, for example, answer 1 is preferred over answer 2 with 0.9 probability. How do you get these strength values? Because you don't rely on one person to ask. Normally what companies do is generate these prompts and ask a whole bunch of people and then see what fraction says this is preferred and what fraction says which is preferred. And then they come up with the strength. There's a way of doing that. So let's assume that answer 1 is preferred over answer 2 at 0.999. Answer 4 is preferred over answer 2 with 0.98. And then answer 3 is preferred over answer 2. Now, one of the problems with the preference model is you cannot do all the pairwise combinations because there's a combinatorial explosion. So you do only a subset. And you hope that the preference model generalizes to the things you never asked people about. So unfortunately, what happens is, even though 1 is preferred over 2 and 4 is preferred over 2, which is correct, but there is a slight difference in the strength, and now I have not asked 1 over 3 and 4 over 3. Slight perturbations in those. 1 is preferred over 3, which is good, but 4 is preferred over 3, unfortunately. So effectively what we found is, by doing a theoretical analysis, that it generalizes. So you do this preference model training, this area is good, it adheres to the values as we think about, but these are what we know as instability regimes. That there the preferences for unknown things which we never trained for can flip very much depending on those scores. Okay, then also we found that what was traditionally what has been used by Bradley-Terry model, there is a general version of that called the Plackett-Luce model, in which for one prompt you give n number of responses and you rank order the responses, right? How do I commit suicide? First, this thing is, sorry, I can't tell you, you seek professional help. Number 2, you say, I cannot tell you. Number 3, why are you asking? Number 4, here, buy a rope or something. So you can rank order them, right? So it turns out that instead of binary good response, bad response, if you just add one more and 1, 2, 3 and say good, okay, and no. 3, like you give 3 responses, then this instability regime actually shrinks. And if you add 4 responses, it shrinks further. 5 shrinks further. If you have so asymptotically, if they go infinite responses, it shrinks to 0. But there is a problem, because if you want to build this preference data set, you need to spend more money, more annotation, it's more painful. So actually, most of the companies rely on the binary one. But this is a new problem which we have highlighted, that there is an instability regime, and therefore you cannot trust those models. And that's why many of these models actually give bad answers where it should not supposed to give. So this value alignment is an open problem which is as of now unsolved, And I think it requires a lot more effort in this area. Okay, let me now move to my last problem, which I'm going to talk about. And this is a problem of machine unlearning. Now, 3 years ago, when I used to talk about machine unlearning, people say, was there a typo? You wanted to talk about machine learning? No, there's no typo, it's machine unlearning. We were one of the few, in 2022, we are about 4 or 5 groups in the world, we are doing work in this area. We are one of the pioneering groups. Then in 2023, we had some results. And by 2024, this field has exploded. Now, literally thousands of people are working in this area called machine unlearning. And there's a reason why people are working in this. So the idea is unlearning, which is forgetting specific things, right? We know that. And machine unlearning is forgetting specific things from a machine learning model. Now, what we want to do is the following. And our motivation was originally privacy. That you have subscribed to certain service, and then you say, I withdraw, I want to stop from that service. So for example, there is a face recognition model, and you have willingly said, I give my face, so you join a company, and they have a face recognition model to allow you entry or exit access. And then you leave the company, and then you want to be deleted from their face recognition model, right? So basically, I'm going to say, forget me, and then the machine, you do machine unlearning, and the model forgets you. That is what we want to achieve, right? Of course, the natural question you say, what's the big deal? You had the data set of the people in the company, and then you trained the face recognition model. Now you said, I'm leaving the company, so just remove my data from that data set and retrain from scratch. Okay? Yes, that is a solution. It's a solution where it is feasible. And the problem is, if you retrain the machine learning model from scratch for every deletion request, it is compute intensive. Some of these large models have days and weeks of training. For every deletion request, you cannot retrain from scratch. It's too expensive. There's a huge carbon footprint. So we want a more efficient way of doing things. Okay? So turned out, so we have a method for doing this. One very interesting point is, though I use the word forgetting is not same as unlearning. Forgetting for human beings is actually involuntary. You don't control what you forget. In fact, it is very interesting. If I tell you, forget Mohan, the fact if you think that I want to forget Mohan will actually reinforce, and you will probably never forget me, right? So it's paradoxical. But for machine learning models, we want to perturb the weights in such a way that Mohan is forgotten. And in fact, it is possible. So original motivation was privacy. But now people have said there's a lot more applications other than privacy, like deleting out-of-date samples, unlearning outliers, unlearning poison. There could be deliberate poison data in your data set, or there are noisy labels, or there can be biased data, all of that. In fact, the surge in interest today for machine unlearning is also coming from large language models. I told you for preference modeling, right? You don't want your machine learning models to answer if I say, how do I commit suicide? Basically, the model, because of the training data, knows how to commit suicide. It knows how to give. Then you build the preference models and guardrails so that I know the knowledge, but if you ask me, I'll say no. Then you ask me in an indirect way, I say no. And they ask me in a really indirect way, then I say, yes, this is how to do it, because I have the knowledge. So many people are saying that for doing value alignment, for harmful thing, what if we make the machine, the model unlearn? If I don't know how to do suicide, then people say, how do I commit suicide? I said, take a plate of samosas and eat it, because I don't know how to commit suicide. So this is the interest which is coming, that machine unlearning is a way of making the models less harmful, of doing better value aligned. Okay? And we actually have done work unlearning with anti-sample reasoning. So again, we use a toy problem that suppose we want to forget about Harry Potter, where he studied. Okay? We have a way of, just like there is training samples, training data, what we are trying to do is we are trying to create the anti-sample The anti-samples are like training data, which will have the reverse effect on the gradients and the model parameters as what the learning does. And if you can do that in a very principled manner, it is a bit complicated because actually knowledge exists like a concept graph, and just removing one node is not enough. You can indirectly reach through the other nodes. So it's a bit complicated, and a lot of people are working into this, and therefore there is this huge interest and excitement in this area. Okay? So basically I'm coming to an end of it. So I think there is a huge amount of opportunity, I think, in this area. AI in general. I think I've listed a few: tackling misinformation, and I think building Indian multilingual large language models, I think, needs to be. I think we have some experience doing there, where ASEAN languages. Also building Indian multimodal foundation models. I don't want stable diffusion to be used in India, where all the images it generates or the videos it generates are Western, or Chinese for the Chinese models. You would like Indian, scenes and scenarios and Indian sensibilities, Indian cultural nuances to be captured in this model, right? And of course, how do you do effective value alignment of Indian foundation values? Because India is also a very complex, multicultural kind of, we have all the regional, differences and all that. And we need our foundation models to reflect the Indian cultural values out there, okay? And for hallucination, I think the trend is you have to use these large language models with some deterministic, provably accurate systems. And my favorite example is if you're using LLM for a financial application, don't use LLM as a calculator. LLM is pretty bad as a calculator. You can train it to become better and better. But actually, you have deterministic calculators which can do very good calculation. So your LLM should invoke an outside calculator to do any calculation and then use the data, but still check for hallucination when it outputs anything. And in fact, the hype for this year is agentic AI. And in a way, people are recognizing that just using generative AI is not good enough, and we need agents which specialize in, and you orchestrate a combination and coordinate them to do that. And of course, there is a huge opportunity in applications, healthcare, agriculture, education, law. I know there are a lot of initiatives in India, and I think there's a huge amount of potential out there. So this is my last slide. I think AI has, I hope I have convinced you, based on some of the work we have done, that there is a lot of potential to do good, but it needs to be properly harnessed, and there are a lot of downsides, and I've been working on a lot of the AI safety and security issues. We need to mitigate that. So AI has generated a lot of excitement, and there's a lot of hype as well. And also there's a lot of apprehension. Like a lot of the creatives are very worried, making posters, images, songs, videos, everything with Sora and all that. And people are worried about job losses. And it is a very interesting times. How will the future pan out? And I'm very happy to have later on offline conversations. I think there is reasons to be optimistic. There are reasons to be depressed also. And we need to kind of have a very balanced perspective on that. Personally, as a computer science professor, I think this is one of the most exciting times to be doing research. Thank you.